Hey, we're back here at the Nexus User Conference in the customer success strategy track. We added this track because, in general, people, unless they own the Nexus platform or the Nexus product, they don't know what's available as far as customer success and what kind of support we can provide. So I'm going to have Chris Carlucci kick this off. Morning, Chris.
Hey Mark, how you doing?
Doing good. I'm excited about this track. We haven't done this before, that we're actually going to have your whole team virtually
Right.
talk about what they're doing. So I'm excited to hear about that. You want to give us a rundown for what's going to happen today?
Yeah, absolutely. Appreciate everyone joining today. I'll be kicking off a series of presentations that's conducted by the Sonatype customer success team, as Mark just mentioned, that's going to discuss various aspects of Nexus solutions as well as open source usage and the patterns we see across the various organizations that we work with. And I think you'll see a variety of topics ranging from what makes a successful customer to how to deal with open source policy and licensing within that policy and others that come up.
Excellent. If you want to share your slide deck, I will get out of your way and get you started.
Perfect. Let me get set here. All right.
Oh, that's a nice start.
There you go.
Beautiful. There you go. All right, good. I'm going to back out and I'll see you in a bit.
All right, perfect. Thanks. So as I said, appreciate everyone joining today. We're looking forward to the sessions coming up, especially the customer success track, but all the great sessions we have lined up for today. As I mentioned, we'll be talking about our experiences with the customer deployments, as well as just trends that we see in open source usage. In my session, I'll focus on what organizations are doing to better manage, track, and monitor their open source consumption by utilizing automated tooling and changing their development culture. First, though, I'd like to discuss why this is an area of need for organizations to set the context on why they're starting to take these steps. And really the main driving factor of organizations taking these steps is the use of open source is exploding, right? So we see tens of billions of downloads per year from popular repositories in main ecosystems such as JavaScript, Java, and even in the container world, right? And we see over 1,000 new projects are created each and every day, right? And as a result, we see or know that up to 80 to 90% of a modern application actually contains or is assembled from these components, most of which are open source components, right? So the way that the application is being developed has changed mightily over the last several years, and this is instigating a change in our development processes and how we need to look at the problem area. And most of that comes from the fact that we know that these components aren't created equal, right? Some are healthier than others, some are older than others, some have metadata associated with them, such as vulnerabilities or licenses that could pose risk to the organization that we need to be aware of. And that may change over time, such as new security vulnerabilities that are present or becoming several versions back on a component, which could create technical debt within your application. And really, the usage has become so complex that it's impossible to manage it manually, right, with any efficiency or to any effectiveness, right? And this is really because, like I said before, the volume of downloads, tens of billions of downloads, organizations are consuming these, in the thousands per month across hundreds or thousands of applications. There's 14, on average, 14 new versions of these components coming out each year, right? There's a diversity of the projects. As we mentioned before, not all components are created equal. This doesn't even start to look at the transitive haul that comes into the application as well, right? So you download one component and that may pull in, tens or hundreds of other components because it relies on them to actually run. And those are the transitive dependencies that get pulled in. So being able to track those as well is also important and part of the total picture of what goes into the application, right? And the way we think about this is a supply chain problem, right? So imagine if a car manufacturer such as Toyota didn't know where they were sourcing their parts, didn't know the quality of those parts, and didn't know what cars those parts were going into with any level of consistency or accuracy, right? It would create probably hysteria from a lot of the world, but imagine if they had to do a recall, right? And this is on the premise that they could actually determine that they needed to do a recall because they found out that one of the parts they were using was defective. They'd essentially have to ask everyone that owns a Toyota to come in because they potentially might have that part that potentially has the problem, right? And that obviously would not be a good way of doing business, and it's not the standard that we expect from areas such as car manufacturers, right? And if you think about the application space, that's kind of the space that we're in right now, in that we cannot always accurately identify the components that are contained within our applications, despite the risk associated with them, despite the quality aspects associated with them. So what we really want to do is be able to embrace these supply chain principles to bring that vision into an insight into what's in our applications, right? And that's really starts with sourcing high quality parts from trusted suppliers, and the ability to trace those parts wherever they're integrated in those applications so that you can quickly determine what the risk associated with those components may be, whether in development or in production. And what we see is that organizations who start to do this see tremendous gains in developer productivity, decrease in unplanned and unscheduled work, and reducing technical debt. And this is all while also reducing security and licensing risk, as well as maintaining any regulatory or compliance needed, and better component hygiene, right? And I think it's probably no secret for those attending this conference that to get started and where you need to begin to get a handle on your component consumption is first with a repository manager, right? So if we start to take a look at a simplistic view of an SDLC without a repository manager, as we build out this slide, we see that developers are pulling in open source components, third-party components straight from the internet. That gets committed to their source control, which then goes off to the build, which is usually automated through a CI tool such as Jenkins or Bamboo or TFS. And then that build, when it doesn't have all the transitive dependencies that it needs, again, goes directly out to the internet every single time to grab those components that it needs on demand. And eventually you produce some artifact, some output of the build that goes into production, right? So in this case, these components are stored either in the source control, the build system, or on a file share somewhere, which is bringing a lot of inefficiencies into the process. So if we institute a repository manager, in that same view, we see the developers are actually reaching out to a repository manager like Nexus OSS or Pro, and that repository manager is proxying out to these public external repositories and then caching those components each time they're downloaded for reuse by that development project team or any other team within the organization. And then the same thing occurs, right? The fixes get committed to source control, that goes out to your build CI system, and now that grabs the components it needs from Nexus, and if Nexus doesn't have it, it will go out one time to grab those components and then cache them locally. So again, they're available for reuse, and again, ultimately you push something out into production, which can then be stored and released through the repository manager. And all of this results in many benefits, right? Whether it's decreased build times, reduced bandwidth, enforcing component naming conventions, or standardizing the release process, right? There's various benefits that come from instituting that repository manager from both an efficiency and development effectiveness standpoint. And so this starts to give us insight into component usage from a repository perspective. But as we mentioned before, ultimately those are ending up in the application to the tune of 80 or 90%. So we know that we need additional automated tooling that allows us insight and continuous monitoring of those components within the application context, again, where it's being built within the organization. And we know to be able to operate at the speed of DevOps and automate in that environment in a modern day application development lifecycle, there are certain requirements that that tooling must be able to do or have. And the first and foremost is the scans need to be fast, right? So you're scanning hundreds of thousands of applications and their transitive dependencies every day, right? It needs to be able to operate at the speed of your build so that it can scan synchronously and give you real-time feedback without any degradation to your build, or minimal degradation or build, rather than asynchronously after the fact, right? And depending on how long that may be, it may be too late for those results to have any impact on the current application development. When it does produce the results, they need to be very precise. It's not enough to be at the group and artifact level. You need to be down to the version level, which makes a world of difference when we're talking about differing versions that may or may not have, for example, a security vulnerability. Just as we said, not all components are created equal. We know not all applications are created equal, right? So we need some sort of guidelines based on the context of the application, such as whether it's distributed externally, it's a hosted service, or it's completely internal, or that it contains sensitive data or must maintain compliance, right? Some applications may have stricter policy constraints because of these than others. So we want to make sure that every result that is provided is a true positive in the context of that application. Then it's not enough to actually have the results. You need to know what to do with them, right? So you need some mechanism to report to the developers, to the end users, on what must be fixed and how to actually do it, and remediation guidance to do so. And then lastly, you do all this work to make sure that what goes out into production is approved and up to your standards. But once a application is out in production, you need a mechanism for continuously monitoring that production application, because the contents of it may now differ from what is now in development, right? Consider version 1.0 to 2.0, right? So it needs to be continuous, not only on what's in development, but what's out in production. So if we take a look at where we can start to institute an automated tooling like the IQ server within this process, we see that there are integration points that need to occur where the developers are actually sourcing the components, building those components. So the first thing that we're going to see is an integration point from the repository manager to developers, so that when they're sourcing components, there is a guidelines, a policy provided to inform them of whether or not this component will ultimately pass policy within their application. Second, within the IDE. So as they're continuously working, even before they get to the build, integrations into the IDE, so that you have a view while writing any fixes or new features, and integrating those components, you can see in real time which components would pass that policy. Then another integration point at the build, as we mentioned before. So each and every time you build, you know exactly what's going into that application. Ultimately, once it goes out into production, you want a scan that happens before that. And then, as we said before, we need a way to continuously monitor that production application. We also know that a tool is not a process, right? And a process is not a tool. So the tool is not the sole answer. We also need a process that must be established around this to set expectations, train those developers, and track progress to continually make those improvements, right? So we need to start building a better bridge between these various groups that are involved, like development, security, operations, et cetera. And if we take a closer look at those folks that do get involved and the responsibilities they do have, we start out with the what we call policy participants. And these are subject matter experts from the various parts of the organization, whether that's architecture, security, legal, if there's an already existing open source group that helps us define what the guidelines should be, what are the criteria that developers should work by, so that they know what is approved within the organization. We then have our integration participants that are going to help us actually integrate into that development lifecycle, from build engineers, but also development managers that control the developers' times, or at least guide the time and objectives for those developers. And then lastly, our participants that are going to interact with the tool itself, right? So generally we see a sponsor that is running that initiative, project owner that is a little bit more hands-on with the deployment, helping developers get integrated, and then lastly, the developers and users, right, who are going to see the results and have to act upon those results and ultimately live to the standards of what's in their application. So if we start to see where these people fit in the process, as I mentioned before, we have our developers, but we also need our policy team, which is going to help us create those guidelines. And when we have our project owner, that's going to help with things such as managing policy and exception handling within the IQ server, right? So all these groups start to come together and fill a role to help us embark and be successful on this process. Once we have those folks in place and we understand a general overview of what we want to accomplish, we see organizations go through a few different phases on their way to starting to build better insight into their applications and components contained within them, right? And we start off with discovery and inventory. And really, this is the process of understanding how your organization builds and releases software. Without knowing the inputs of where the developers are working, where components are going in, where they're coming out, we can't really understand or build that application inventory to be able to assess and initially and continuously monitor those components going forward, right? So once we have this information, it'll start to help us determine the number of applications in scope, how the applications get integrated, how you want to structure those applications within the tool, who does what, and the application types. As I said before, not all applications are created equal. We need to understand what type of data they contain, how they're externally distributed, and any other policy constraints that may apply to them that may not apply to others, so that we can have those contextual findings. You'll want to decide on how exactly you're going to approach the deployment with developers, right? So there are two main thoughts here. The first is a centralized approach, which is a smaller group of administrators that control most of the actions that occur within the process. And this gives you a lot of control and visibility over every single action that's occurring within the process. So there is a benefit there. However, it's not an effective way to scale across an organization, even of just 50 or 100 applications, much less 5,000 or 10,000 applications, which we see across large enterprises. And so what we really recommend is a federated approach, where you start to federate out those responsibilities to the application teams. For example, giving some of those responsibilities to a dev lead or a dev manager to oversee and be responsible for their team's coding guidelines, right? So I like to think about it as another part of the definition of done, right? Did we pass policy after this sprint with any components that we introduced or any metadata on components that changed, right? If not, we need to take a look at that, or else we're going to start to build up technical debt, right? And a dev lead or dev manager should be the appropriate party to be trusted with that process, and also make sure that they can follow through on that. Once you've done that, you need to understand what are the actual guidelines for developers to follow, right? And this is where the subject matter experts come into play. And we refer to it as a policy, right? Your open source policy. And, trying to simplify matters as much as we can, we really try to answer the question, what is the main purpose of policy first? And really the answer is to drive some sort of intended behavior, right? So if we look at real world examples of policies that are common to us, such as a no smoking sign, right? Smoking is not desired in that area. Speed limits, drive in and around this speed limit because the behavior is deemed to be safer, right? Something you probably tell your kids all the time, don't run with scissors, right? Why do you tell them this, right? You're trying to drive their behavior towards other actions that you deem more appropriate, safer, right? And then something as simple as password strength are all common examples of a policy in a real world context. So we take a look and translate that to policy in the IQ server. We believe it's a set of guidelines that's going to allow you to easily identify and reduce risk within your open source consumption. And we do so by defining traits and relative risk of bad components. So it's a blacklist. And then ultimately, what action is required once you have those results? Is this a must fix or not? And how do I go about doing it? Right. So at the end of the day, policy is your way of deciding what is and is not important pertaining to component consumption, either within your application team, within your business unit, or across your organization. And there's 4 main areas of policy that you want to be considering, and that is a few obvious ones such as security vulnerabilities that are associated with those components because they contain the potentially vulnerable code within the source code. License risk, which are licenses associated with open source components, and these licenses are made up of obligations, and obligations are requirements that the end user must adhere to in order to use those components. Some of these requirements are very liberal or less restrictive, and some of them are more restrictive and may cause you to have to do something you don't ultimately want to do. And so knowing what those licenses are and the obligations associated with them can become very important. There's also architecture, good component hygiene, right? So if you start taking a look at component age, the older the component, it's been shown that the more vulnerable it tends to be. Popularity of that component. Are you on a version that is not widely used? Do you want to get to a more used version of that component? And other aspects such as like build cleanup, right? Is there any reason a test component should show up in a production application? This is something that we generally see when projects migrate from Ant to Maven and they don't get the scope set correctly, right? Best case scenario, it's just a component that poor coding standards, right, within the application. Worst case scenario, there are some test components that have known to have security vulnerabilities. And then lastly, the match state, which is essentially the authenticity of the component. Is it the authoritative version, the original version, or has it been modified in some way, either by some third party or your development team along the way? And these can have obvious implications, whether from a security standpoint or a licensing standpoint. Once developers have those guidelines, they can start taking the next steps towards remediating or mitigating any risk that exists. And that boils down to a few key areas to keep in mind, and that is communicating proper expectations, making sure that findings are actionable, and then your overall organizational philosophy. So if we take a look at each one of these in a bit more detail, first and foremost, communicating expectations, right? You as a project team have the responsibility to ensure that the tooling is generating valid issues, right? Developers should focus on remediation rather than validation of the findings, right? And the lack of clarity of this can lead to frustration, bottlenecks in the process, or just a lack of trust in the tooling, right? So you really want to limit the mandatory issues that developers are going to receive so that it's actually actionable, right? So, folks who are ever used any security or quality tooling, in the past are probably familiar with this type of scene, right? Where every issue is critical. The problem is if everything's critical, nothing's critical. And at the very least, it's a sensory overload. You don't know essentially where to start. And there's just a lot of skepticism around the results, and there's a cost of doing business, right? We cannot focus on every single thing. So how do we take off bite-sized chunks to work towards overall better component hygiene, right? So we'd like to see something closer to this picture, right? Which is much more actionable, and the threat level actually denotes priority, right? So you can then give advice towards fixing the red, right? Whereas in the previous picture, everything was red. Now we've called out the most critical pieces of that risk that the organization wants you to focus on. And oh, by the way, you now have this other information in front of you should you want to take on that work within your development cycle, such as upgrading the version of components, right, to start decreasing the technical debt that the team has taken on over the years, right? So hopefully this information empowers developers to start making better choices while also maintaining that compliance that the organization is looking for. And then ultimately, we're all too familiar with the scan and scold, mentality, where there's a lack of transparency of the information that exists. When it comes to light, it's generally too late, and it ends up with a scolding mentality, right? And it's hard to make any progress in this state. What we like to promote is more of a support and guide method, right? Where all parties are on the same playing field of information. All right, so it promotes that transparency. Hopefully, as I said before, empowering developers to make better choices by giving you the information as early as possible in the life cycle, right? As we talked about, from sourcing the component to write in your IDE so that you have all the information readily available. And then hopefully we're initiating constructive conversations rather than a scolding mandate at the end of the release cycle. And once you progress through the initial remediation and mitigation phase, you get into enforcement, right? This is the actual mandate that certain things must be fixed or else the application cannot be released, right? And a few key areas that we want to keep in mind here are the culture and maturity of the organization at the start of this process, right? So it's really an honest assessment of your current organizational maturity, but not necessarily with just open source consumption, but software development as a whole, right? So culture will help define early actions. So when we help out organizations, we're really trying to get that sense early on so we can understand the best steps to take given that organization's maturity. Some organizations are in a fail fast mentality, right? And they like failing to build for these types of issues, in which case we can integrate right into that process with help of the development team. But there's other organizations that do not have that type of culture. And so we do not want to start setting that precedent early on. We need to give developers time to react to those findings. And then ultimately we could reach a point where enforcement actions are integrated. But even with that, it may be wise to warn early and fail late. And what I mean by that is anything that you ultimately know cannot be released, right? It cannot get out the door. You set a warn, right? So it makes the build, quote unquote, unstable, right? In Jenkins terminology. And this is your way of informing developers. Anytime that happens, know that this will not get out the door. I'm not going to block your build. I'm not going to stop you from proceeding and making the change that I'm actually asking you to do, but this is your indicator, right? That this ultimately cannot go out into production. And so it's a kind of a hybrid approach to adding enforcement, but also doing it in a way that is, approachable with developers. And then lastly, even despite having what we refer to as a component governance workflow, we still want to promote component selection, right? So what we've talked about the last few minutes is more governance, right? This is what must be done in order to adhere to our organizational standards, this mandate to fix these issues, right? However, we still want to maintain some semblance of a component selection workflow where we're assisting developers in choosing better components. And this occurs when developers are empowered with this information to investigate the various choices that they have, again, as far left as sourcing that component and within their IDE.
Chris, just a heads up for a 3-minute warning.
Sure, thanks. So if we take a look at this, these phases again, just to kind of recap, remember discovery and inventory is really understanding how your organization builds and releases software so that we can start to get the inputs and understand where we need to integrate and start building that application and component inventory within the IQ server. We then have policy defined by our subject matter experts on top of that to help us understand what are the guardrails, the guidelines that we want to adhere to, but also empower us with the additional information on these components that wasn't previously available, prior to instituting automated tooling. We then get to the point where we actually want to do something with it and start getting value out of it, and that is mitigating any current risk or component hygiene or technical debt that does exist by taking action on those components. And then lastly, some semblance of enforcement on what must be done before it goes out into production. Of course, even with all of these, benefits and areas where organizations can make this a more successful process, we do still see where organizations are challenged, and you guys may have run into that as well. And the first one is failure to embrace that change, right? So changing process is changing culture, and that's a difficult thing to do and takes a lot of effort and a lot of support within the organization. And then when you start to lose that support, or there's turnover, or there's new initiatives, or there's reprioritization of those initiatives, you start to lose momentum with that effort that you started. And then lastly, making sure that you have executive level support that has the ability to mandate that change and make sure to follow it through. Right. And within our successful customers, despite those challenges, we see that they have these main qualities, right? So having a strong executive sponsor that has the ability and the willpower to see that through, right? Setting expectations from the start, defining what success actually means. What is the primary desired outcome of what we're trying to achieve, and how are we going to actually measure that? So it's not just the value creation, but it's also value realization. And you may have heard yesterday, we just launched our SonoType community site, which is a place for not only organizations to interact with Sonatype, but to interact with other organizations. So I'd encourage you to get involved there to help collaborate and communicate and start the discussions around where you guys are at in your organizational maturity, starting to build better component practices, discussing with each other and leveraging your experiences with each other, as well as Sonatype, to help start solving these problems and making progress towards building those better component practices. So I think I'm right on time here, Mark. I appreciate everyone's time today. Hopefully this was beneficial. I'll be in the Slack channel, for the next 15, 30 minutes. So feel free to ask any questions, and thanks again for your time.
Hold on there, Chris. You did a good. As I was making notes, I was trying to take notes, and there was just too much good stuff there. I'm going to have to scrub back and and listen. But there's a couple points I want to talk to.
Sure.
Yesterday, DJ Schleen from Aetna said exactly what you said about, go ahead and warn somebody early, but fail them late. Let the build move forward. With the team having knowledge that's, let me turn my camera on too so we can talk here. But I thought that's fascinating because we hear so much about break the build immediately. And then we heard yesterday from DJ on a huge one, let it move forward. What's the history on that? What do you got with that?
Yeah, so obviously by failing the build, it's a blocking action. But in reality, the first thing you need to do in order to fix the problem is to run the build, right? Build successfully. So if you think about it from a production application standpoint, if an application is in production and there is a new vulnerability that occurs and you need to fix that, the first thing you're going to try to do as a developer is to build it, right? And if the build is failing because of that exact thing that you're asking them to fix, it creates a prohibitive action for you to actually proceed, right? So the thing I like about the warn early is that it sets the expectations, but allows developers to proceed, right? Obviously, there needs to be some trust on multiple levels between the project sponsors as well as the dev leads and dev managers of what those expectations are, but it creates a more seamless option while still providing the organization the ability to have those controls in place prior to going out into production.
And then there were a couple slides in there I thought they were fascinating. One, let me just go back and look at my notes too here. The first one is when the 5 circles that you had, you might even pull that one back up with the discovery, the inventory, the policy. When you're looking at that, is that almost a mini maturity model that you can look at a company and say where they are within that phase and say how mature they are?
Yeah, absolutely. It's definitely something that can be used on that case. Like I said before, the first thing you need to do is start with the repository manager, right? If you don't have a repository manager in place, when you get to these phases, it's going to be very difficult, even despite all the challenges, we mentioned above and beyond those. So once organizations have started to make the decision to go down this path, these are definitely the phases and maturities that we see throughout the organizations. And when you can reach that mitigation and enforcement phase, that's obviously starting to get towards, the holy grail there of instituting better component practices, driving down that legacy risk that exists, but hopefully pushing left in the process such that you're stopping the bleeding from the start, and in parallel, building better component practices while starting to reduce that existing risk within the organization.
The other big point that you talked on, and you had a really good quote there, and I didn't have time to write it down, but the essence of it was choosing what to remediate first. Remediate instead of something is what you said. I forgot what that was.
Remediate, was it around the component selection workflow?
I think so. It's like I said, I was scribbling so fast, but the gist of it was, first of all, you can't just put everything on somebody's desk.
Oh, right.
You got to do it.
Gotcha.
Right?
Yep. Yeah. So I think it was around what's actionable, right?
Yes,
So
yes.
when every issue is critical, right, or if there are multiple false positives within the findings, it's very difficult for developers to actually act on the data, right? So we put the responsibility on ensuring that the findings are actionable on the project sponsors, on those project owners, such that developers focus on remediation, not validation of those findings, right? And even still, it's very easy for organizations to end up with a finding set result that looks much like this, where you don't even know where to start and there really is no direction on what needs to be fixed or what is actually critical. And we want to get more towards this picture, which allows the threat level to actually denote that priority and drive the developer actions. But hopefully this other information is still beneficial once it's integrated, within the IDE, and you have that at the tips of your fingers, which otherwise you may not have prior to the tooling.
So who is choosing what is actionable here? Is that part of an automated process, or is this a decision that has to be made?
That's a very good question. So, harking back to the beginning where I talked about the requirements of actually integrating this tooling within your environment, you need it to have certain qualities, right? It needs to be fast so that it actually operates at the speed of DevOps, at the speed of your builds and agile development. But the only way that it can also work is if you have proper guidelines built into a policy that can quickly, precisely, and contextually inform those developers so that all findings are true positives of what they actually need to act on. And those guidelines are built by the subject matter experts from security, legal, and architecture in terms of a threat level of what is the most severe down to what is beneficial to actually fix, but is not actually critical or mandated, right? And that policy is absolutely essential. Without it, you don't have those guidelines, and that's what bridges the gap between the subject matter experts and those stakeholders and developer expectations. I think you're on mute, Mark.
Yeah, I'm talking to myself.
Yeah, no worries.
That's the way my kids usually hear me too. It's a selective hearing. But I think even though, I deal with you guys every day, when I hear a talk like this and you give the complete picture, it's fascinating because there is a process for getting this to be done. Very happy to have your session here. Just Melanie and Jerry are going to come on in about 10 minutes. We're on a break. But you want to give a brief overview of what they're working on?
Yeah, so they decided to tackle a very interesting topic, which is open source licensing. So I touched on it briefly earlier. I didn't want to steal too much of their thunder, but one of the criteria of being an open source component is that you have an open source license, right? And so these licenses are going to dictate the terms of service of use, essentially, for that open source component. And some of them have obligations that are very restrictive, and some of them have obligations that are very nebulous, right? It's hard to make anything of them. Developers aren't lawyers. We don't want them to be lawyers. We don't want them to spend time on investigating licenses, right? So we create policy from the subject matter expert in the legal space that allows to define those guidelines so that they can quickly see, does this component have a restrictive license? Let me get on a component that does not, right? So it's a very interesting topic. There's a lot there. I'm looking forward to it as well.
Excellent. Thank you.